Have you ever looked at the tag on a piece of clothing you were thinking about buying and seen recycled polyester listed as one of the materials? If so, you may have worn a shirt made from water bottles you've thrown in the trash. The world produces more than 400 million tons of plastic each year, but only about 9% of it is recycled. Plastic water and soda bottles often contain a chemical called polyethylene terephthalate, PET. Using PET bottles to make recycled polyester produces 75% fewer greenhouse gas emissions than making new PET. Using recycled polyester to make new fabrics, on the other hand, uses less energy and resources. You're using plastic that already exists to create new materials, so you don't have to take coal and oil from the earth. So how is recycled polyester made? Let's take a look at the process now. With the increasing awareness of people, the collection of plastic bottles has become much more convenient. Through the civil collection system, plastic bottles are collected to the processing plant. This is very meaningful because it determines the cost and scale of the following stages. After being collected to the recycling plant, plastic bottles will be carefully classified. We need PET plastic for this process, so sorting is very important. The optical sensor helps to sort the plastics based on the principle of interaction between light and matter. Because different plastics have different chemical compositions, which leads to differences in the way they absorb and reflect light. From there, the machine analyzes the spectral structure and accurately sorts the plastic. Plastic bottles are also sorted based on color. Transparent plastic is separated because it can be made into white fabric or easily dyed in other colors. The PET bottles are stripped of their caps, labels, and glue through a washing and soaking process. Now these plastic bottles are crushed into small pieces. This crushing process causes the plastic bottles to break into pieces of 10 to 12 millimeters in size called flakes. These flakes are put into a water tank where the heavier PET flakes sink to the bottom. Other lighter plastic flakes that float to the top are skimmed off the surface. The PET flakes are washed several more times to remove any remaining dirt or glue. And finally, we get clean and pure PET flakes. Because they are still wet, they are dried, the water evaporates, leaving behind clear flakes, which are the PET flakes. These clear flakes are bagged and ready for the next process. These PET flakes will be melted in furnaces at temperatures up to 260 degrees Celsius, along with the pigments. The temperature needs to be precise at this stage, as it is high enough to melt the plastic but does not destroy the molecular structure of the PET. This allows us to create strong fabric while still retaining the good properties of the plastic. The liquid plastic is forced through a metal screen with tiny holes. As the liquid plastic flows through, it forms long, thin strands. These strands are cooled immediately to hold their shape, then collected in tanks below. This is the polymer. Polymers are very large molecules made up of many repeating units called monomers. Think of a bicycle chain. Each link is a monomer, and the entire chain is a polymer. This structure gives PET its extremely special properties, making it strong, impact-resistant, transparent, and chemically inert. The original plastic fibers are weak and lack strength. They are stretched repeatedly under the influence of heat to bond the polymer molecules, increasing strength and toughness. The polymer fibers are stretched by the spinning machine to become longer and thinner. This process requires high precision. If the fibers are drawn too fast, they may break. If they are drawn too slowly, they will not be thin enough to create the soft fabric we want. After this process, the plastic fibers achieve a uniform thickness and size, suitable for producing polyester fibers. The stretched plastic fibers are processed to form small, cotton-like clusters. This is the raw material for making polyester. It takes 2 stages to convert cotton into polyester. First, the polyester fibers are combed so that the fibers lie parallel, increasing their strength and preparing them for weaving. Then the fibers are fed into large looms to form raw polyester sheets. This process requires precise coordination between thousands of fibers. And the result is fashionable and durable polyester fabrics. These sheets can be treated with small loop machines on the surface, then using wire brushes to soften them, making them more pleasant to the touch. They are then cut to shape and sewn into fashion products. Every year, the recycling industry creates millions of meters of polyester fabric from plastic waste. This is a living testament to the power of recycling. Did you know it only takes about 9 plastic bottles to make a t-shirt and about 11 plastic bottles to make a pair of shoes? To create new polyester, you need to start with coal, petroleum, air, and water. These materials have to undergo a chemical reaction called polymerization at extremely high temperatures. This means that creating new polyester uses a lot of energy and natural resources, which is not ideal. It also adds greenhouse gases to the atmosphere, which is harmful to the climate. So recycling plastic can solve the raw material problem while also being a sustainable solution for the future. Now, every time you sort a plastic bottle in the bin, you are contributing to a more sustainable supply chain. A world where plastic is not a problem, but a solution. From seemingly useless plastic bottles, we can turn them into fashionable, sustainable, and environmentally friendly clothes. Every time you wear a recycled shirt, we have contributed to solving the problem of plastic waste. Let's make small changes together, classifying trash for a cleaner future. Thank you for watching the video. Let us know your thoughts in the comments below. Don't forget to hit the like and subscribe buttons to support the channel. For now, goodbye and see you in the next video.